is called three-valued conditionals. And that's because that's what it's about. So, as we all know, according to the equivalence thesis, a conditional if A then B is equivalent to the disjunction not A or B. So if it's raining, then it's cloudy. It's the same as it's not raining or it's cloudy. So as I've written it here, this thesis has two halves. Not A or B entails if A then B, and conversely, if A then B entails not A or B. And as I think everyone here would agree, this thesis, although it's kind of orthodox or part of classical logic, is not very intuitive. So you might wonder, why would anyone accept this? And at least in the context of the classical logic, there's a simple argument why you should accept it that goes from modus ponens and conditional proof and other things that are classical. So this argument, I think it's important because it's one of the main reasons we have for taking this thesis seriously. And it's also one of the main things you can use when you try and convince students that it should be this when you're teaching, is to give them this argument. If you just go through the truth table, the students are often unhappy. Often they're less unhappy with this, even though, as we'll see, perhaps they should be unhappy with this as well. But they'll be a bit happier with this than the truth table. So I see it as the main reason for believing the equivalence thesis. Okay, so the argument for the left to right half that not A or B entails if A then B, it just relies on two things. One is called conditional proof, the other is disjunctive syllogism. Okay, so conditional proof says if you have an argument with some premises, then you can move, and it's valid, then you can move one of the premises into the antecedent of the conclusion, and it will still be valid. Sometimes people call this the deduction theorem. Here I'm using it more like as a premise, so I don't like calling it the deduction theorem today, so I'm calling it conditional proof. And the other thing is disjunctive syllogism. It says if not A or B and A, then B. You apply conditional proof to the disjunctive syllogism, and you get the left to right side of the equivalence thesis. Okay, so if you accept those two things, you have to accept that half of the equivalence thesis. Okay, this is the more controversial half of the equivalence thesis, I think, but I want to go through the argument for the other half as well. So it says, it relies mainly on excluded middle and modus ponens. So we want to show that if A then B is true, then not A or B is true. Well, suppose if A then B is true, then from excluded middle, either A is true or not A is true. Okay, but if it's A that is true, then we get B by modus ponens because we suppose if A then B. So we have not A or B. On the other hand, supposing not A is true, then we also have not A or B with disjunction introduction. So either way, we have not A or B. Okay, so the reason this is a talk about three-valued logic is because it's interesting that in various three-valued logics, both of these arguments fail. So in particular, in three-valued logics in which the third value is interpreted as both true and false, okay, disjunctive syllogism is invalid. So this argument is no good. And in three-valued logics in which the third value is interpreted as neither true nor false, then excluded middle is no good. And so this argument is bad. So you might hope that if you change nothing else, if you keep modus ponens and conditional proof and adopt a three-valued logic instead of the classical logic, you might hope that the right conditional just falls out. Initially, I hoped that that turns out not to be the case. And so then I put this paper on the back burner for a long time and didn't think about it again. But then I thought, even if this isn't like, none of these conditionals are a good candidate to be kind of the right conditional in natural language or something like that, it's still interesting to know which conditional it is that satisfies conditional proof. Because conditional proof, it kind of tells us that this conditional is closely related to valid arguments, and you might want a conditional that expresses that. So even though It's definitely not going to correspond to the natural language conditional. I still think the conditionals discussed here are interesting to consider. Okay, maybe at the end, if there's time, I'll say one other reason why I think the topic is interesting. Okay, so first I'll talk about logics in which the third value is neither true nor false, and there'll be 3 of those. And then I'll talk about logics in which the third value is both true and false, and then there'll be 3 of those, and then we'll finish. Okay, so if it's neither true nor false, the truth tables look like this. For negation, it's the same as normal, except when a sentence is neither, its negation is also neither. For disjunction, it's the same as normal, except when one value is neither and the other is false, or both are neither, then the whole thing is neither. So for an argument to be valid in logics like this, it cannot be that the premises are true and the conclusion is false or neither. Neither and false are basically bad, true is good. Okay, so if you accepted the equivalence thesis, the conditional would look like this. You get this just by combining the truth tables for not and or, basically. But it seems like this truth table for the conditional would be undermotivated, okay? Because the arguments that we looked at before, neither of them are going to work if we take this as our truth table for not and or. Okay, so in particular, the right to left direction doesn't work anymore because we don't have excluded middle. Okay, so we reject the premise of that argument, but we still accept the conclusion, and that seems undermotivated. Moreover, the other half doesn't work. The argument for the left to right half doesn't work, okay, because conditional proof doesn't work in this logic, okay, because it's valid in this logic that P, Q, therefore Q, okay, because if Q is true, then Q has to be true. But P, therefore, if Q, then Q is not valid, because if P is true and Q is neither, if Q, then Q would be neither. But if conditional proof were right, we could go from the first argument being valid here, we could apply conditional proof, and this would be valid. Okay, so conditional proof is no good, so we don't get to accept the left to half side either, even though, since this is just drawn up using the equivalence thesis, we accept that both the left to right half and the right to left half is good. So that seems to be a bad thing about K3. Okay, you'll notice here that this is a failure of the law of identity, like if P, then P. But you might think kind of, even if it's neither true nor false that Mike is bald, you might think that if Mike is bald, then Mike is bald. In which case, you might want if P, then P to be a tautology. So you will change the middle value in the truth table to make the conditional true when the antecedent and the consequent are both neither. This is what, so K3 is named after Kleene, that's why it starts with K. This is named after Lukasiewicz, so that's why it's called L3. And it's named after him because he suggested this truth table. Okay, so in this case, law of identity will be good. The right to left direction so excluded middle will still fail, of course. Okay, so the argument for the right to left direction will fail, but that's all right because the right to left direction isn't the case. Because supposing P and Q are both neither, then if P, then Q will be true, but not P or Q will be neither. So if P, then Q will not entail not P or Q, which seems fine. Okay, but conditional proof is still false in L3. Okay, because supposing P is neither and Q is false, then P and not P will be neither. But if P and not P, then Q will be false. Okay, but explosion is valid in L3. So P and not Q will entail Q. But if we apply conditional proof to that, we'll get if P and Q, then if P and not P, then Q. But that's not a tautology. because if P and not P, then Q can be false in the case where P is neither and Q is just false. So we can fix that. Okay, but the left to right direction is still true, even though the argument for it is not good anymore, which seems bad. We can fix that by changing another part of the truth table. So now we change this one from neither to true. In this case, conditional proof will be valid. Okay, and so the left to right direction will be good, but the argument for the left to right direction will also be good. Okay. And so if you accept a logic where some things are neither true nor false, then the argument from conditional proof and modus ponens, it seems to me to support this conditional and not the K3. Okay. As a side effect of this, though, modus tollens is invalid, and so is contraposition, which in this case seems bad. Okay, that's it for the gappy logics. Now he said basically the same thing, but for glutty logics. By the way, I call this one L3 hook. As far as I know, there's no name for it, but there's another logic we're about to discuss called RM3 hook. It's called that by Arnon Avron. And L3 hook is to L3 roughly is RM3 hook is to RM3, so that's why I'm calling it that. Okay, so now we interpret the third value as both true and false. We get roughly the same truth tables. The difference is that now we interpret validity differently. So now an argument is valid if you cannot go from true or both to false. So now true or both are the good guys and false is the bad guys. So it's that change in the definition of validity that makes the difference. If we accept the equivalence thesis, the truth table for the conditional looks like this. And again, just like before with K3, both sides of the argument now fail. So the first half fails because disjunctive syllogism is invalid in LP. In the case where not A is both, okay, then not A or B is both, A is both, but B could still be false. And the right to left direction also fails because modus ponens is invalid if we adopt this truth table. Okay, so it seems debatable, but it seems to be a bad thing about LP that modus ponens is invalid. Okay, so maybe we can fix that if we change this to false. Before it was both, if we change it to false, modus ponens will be valid after all, and then you get the logic that Arnon Avron calls RM3 hook. RM3 hook is like L3 hook. Conditional proof is valid now, since in every case in which the conditional is false, the antecedent is true or both, and the consequent is false, and so the corresponding argument is invalid. Okay, so to get a counterexample to conditional proof, you'd have to have a false conditional, okay, and a corresponding valid argument. Okay, so for the conditional to be false, you'd have to be here or here, and then the corresponding argument would have a conclusion which is true or both. Okay, sorry, a premise which is true or both, and a conclusion which is false, but then it couldn't possibly be invalid. So you can't possibly have a counterexample to conditional proof here. Nevertheless, the argument for the left to right direction doesn't work because disjunctive syllogism is invalid. Okay, but that's fine because the left to right direction is not the case in this logic. Not P or Q doesn't entail if P then Q in the case where P is both and Q is false. On the other hand, the argument for the right to left direction succeeds because modus ponens is valid, and the argument and the right to left direction is in fact true, which is good because the logic kind of coheres with the argument in its support. Okay, so like for L3 hook, the cost of this is that you lose modus tollens and contraposition. So just talk about modus tollens for the sake of time. So in this logic, if P is true and Q is both, then if P, then Q is both. Not Q is also both, but not P is false, okay, because P is just true. So if P, then Q and not P are both true, but not P is false, so modus tollens, this argument at the bottom, is invalid. In this case, I find it kind of intuitive that modus tollens is invalid. So supposing there really were things that were both true and false. Yesterday we sat in a cafe and we weren't sure whether the thing we were sitting at was a table or a bar. Maybe it was kind of both. Okay, let's suppose it's a table and a bar. Okay, still, it's just true that we drank coffee. So you might think it's true that or it's both, that if I drank coffee, then we sat at a table, but we didn't sit at a table. Therefore, we didn't drink coffee. That seems to me to be intuitively invalid. Okay, I tried to test my colleagues for their intuitions and they didn't like this. They said, our intuition is that everything is either true or false and nothing is just both. And they refuse to have any non-classical intuition. But I think you can get used to these things and then you can, at least even if you don't think it's actually true, still hypothetically, we can ask what would be true. And I think it's okay if modus tollens goes in this case. Although the corresponding cases for L3 where it's neither true nor false, I don't find them intuitive. Okay, so we could fix this. If we didn't like this, we could fix it by changing this value to false as well. And then we would get the familiar, there's a mistake here, we would get the familiar RM3 conditional. Okay, and then as well as modus ponens being valid, modus tollens would be valid and contraposition would be valid as well. But the cost of that would be that we lose conditional proof again. So suppose P is both and Q is false, then Q or not Q would be true. But if P, then Q or not Q would be false now. Okay, because we'd be in that row we'd be in that square of the truth table that we just changed, and we just changed it to false. So this conditional is now false. But the argument P, therefore Q or not Q, is valid in RM3 because Q or not Q is a tautology. There's no gaps. So if P is true, Q or not Q has to be true as well. But we can't infer that conditional from this argument. So conditional proof doesn't work. So I think if in the classical logic situation, you like the argument from conditional proof and modus ponens to begin with, okay, then the three-valued Gappy logic you should like is the one I'm calling L3 hook. The three-valued Glati logic, or logic with both true and false that you should like, is the one called RM3 hook. Those are better than LP and K3 and better than LP and RM3. Okay. But there's a trade-off. The cost of keeping conditional proof is that you will lose modus tollens and contraposition. Do I have any time left?
We can do 2 more minutes.
Okay. So I said if there's time, I will say something else about why it is interesting. So I think that people think that in non-classical logic, the material conditional still counts as a kind of default because that's the conditional in classical logic. But if our reason for thinking that the material conditional was an argument like this, and that supports some other conditional, then I don't think it should be a default. So supposing we were applying one of these three-valued logics to the Sorites paradox or something like that, as maybe Zach does, okay, you might think, well, it's okay to solve the Sorites paradox if you think borderline cases are both true and false by accepting the LP conditional and denying modus ponens. But from this perspective, that would seem to be kind of undermotivated because our reason for thinking the conditional and material is kind of pulled out from under our feet. Okay, that's the end.